All right, hi everybody. Welcome to another edition of online Solid Edge training. This is February 7th, 2013. My name is Liam Roney of Edge Design Systems. Today we're going to be looking at using ordered and synchronous modeling. These are two modeling approaches available in Solid Edge. For those of you who don't know, when you think of ordered, think of it as old school CAD, how we've been doing things for the past 20 years, where you draw a sketch on a plane or a profile on a plane and then extrude that out into 3D and then sort of start the process over again, adding more features on top of that where you kind of cut away or add material until you have your part. Synchronous, on the other hand, is not entirely new to Solid Edge. It was introduced in 2008 with ST1. We're now on ST5. And synchronous modeling is sort of combining the power of dimension-driven parametric modeling, but without the reliance on history, meaning you can interact directly with the model. Now in Solid Edge we offer both of these modeling techniques, and we're going to look at sort of where you'd want to use one versus the other and how the two can interact together. And we're going to look at it in the context of an assembly, because in a design, most often we're working in an assembly. So for those of you who are registered on our training list, you've received these exercise files. We welcome you to follow along. Again, these are going to be recorded and posted on our YouTube channel, so you can always, sort of take it in now and then follow it along at your own pace with the recording. So I'm going to jump right into the data set that we've got here. And what we have is we have a set of forks for a motorbike. And we're going to look at sort of a typical design scenario. We've got this much laid out, and what we need is another piece that's going to join these three forks at the top, as well as another one towards the bottom here. And we're going to design that. We've already got it kind of kicked off with the design and kind of look at, where we'd want to use ordered modeling, where we'd want to use synchronous, and how those two are going to help us kind of tackle unforeseen design changes. So if you look at our assembly structure here, the second part in my tree is the beginning of this kind of joining bracket. It hasn't been designed yet, but if we highlight it and go into Edit Profile here, or Edit in Place, what we're going to see is we can see that we've got a sketch already created. And if I just rotate this around, and maybe hide my reference planes here, I'll just uncheck them, we've got an idea of what we're dealing with. So let's think of this in a design context. What this sketch represents is the kind of overall functionality of this part. We've got a general idea of how it's going to span these three members. It's got kind of a clamping system in place. This would be sort of what captures your original design intent. So now to convert that into 3D, and again, I'm in the ordered modeling, so we're doing this old school. I'm going to click on Extrude, make sure that I've got Select from Sketch picked, and I'm going to grab this outline as well as this cutout here in the center, and I'm going to hit check mark. And I'm going to extrude it. I'm actually going to reach underneath and just kind of pick up on the top of this bearing because I want it mounted flush with that bearing. And I'm going to hit Finish. So this isn't the finished part yet, but it kind of captures all of that design intent, the overall design of the part. Now, there's a couple things wrong with this approach. I'm just going to change my view setting here. And the first thing that might be wrong with this approach is that if you think about how 3D modeling works, how ordered-based, history-based 3D modeling works, what all the gurus are going to tell you, what we call kind of best practices, is that you want your part, your features to be as simple as possible. Meaning that if I was following best practices, I may want to start out my first feature to be kind of like maybe just a triangle, maybe with those rounds. Then I might want to add the holes, and this clamping is cutouts. Then I might want to add these rounds in here. And the reason you break that up into separate features is to make it more manageable, a little bit more predictable. And I'll show you what I mean. If I want to make a change to this part, I'd have to click on that sketch. Again, this was defined in the sketch, and I'd have to go into the Edit Profile step of the sketch. And if I just hide the previous level, this is a command that's normally under View. I've added it to my Quick Access toolbar. But if I hide that previous level of the assembly, you see that this is a fairly complex sketch. There's a lot going on in here. Now, whoever drew this, whether it was myself or another designer, we've kind of put these dimensions and set up all these sketch relationships in anticipation of how we may want to modify this part. But as anyone will tell you coming from the design process, nothing ever goes according to plan. You'll always have a change that doesn't quite mesh with how you've set up all this intelligence in your sketch. And the more complex your sketch is, the harder that is to kind of break free of that script. So we see here there's a lot going on, and it may be difficult down the road to modify everything at once from this single sketch. So that's why we have these best practices, where you break things up into simple features. The downside of that, of course, is that I'm making concessions for my modeling tool as opposed to capturing my design. So that's that's a big limitation in history-based modeling. The other thing I want to point out is that remember how I picked up on that bearing. Solid Edge has gone and intelligently created a link, meaning that if I were to move that bearing, the size of my part would change to accommodate that change in position of the bearing. Now that's sometimes a very desirable feature. That's building more intelligence in. The downside is that, again, we may not want that to happen in the future. So links are kind of, and anyone experienced in 3D CAD will tell you that links are kind of a mixed blessing. They give you a lot of intelligence, but they're kind of hard to break free. Now, Solid Edge has made some improvements in the past, made links a little easier to deal with. If we look up in the my Pathfinder here, you'll see that links collect under this link thing. We can actually click on the individual links and delete them. So that makes it a little bit easier to manage. But it's still a piece of intelligence that may or may not be necessary at this point in the design. So enter synchronous technology. Let's take a look at what would happen if I create this feature, and again, this isn't our finished product here, but if I make this feature, this first feature, in synchronous, and then start to build some ordered features on top of it. Maybe that will give us that combination that we're after. So having already created this in ordered, and again, we could have made this in synchronous right from the start, but having created in ordered, I'm just going to highlight the feature in my tree, right-click on it, and I'm going to go move to synchronous. And as we're going to see, you can move any feature you want once it's created and ordered into synchronous. Now it's going to tell me that it's going to break the link if we do that, and that's fine for now. We don't necessarily want that link. And as we're going to see in subsequent trainings, synchronous technology handles linking a lot differently and a lot more intelligently. So now if we look at our Pathfinder and I expand this, you see that we've got this feature lying in our synchronous, but we're still in ordered. We're still editing in ordered. And if I click on that synchronous just to bring me into that environment, you see there's the feature. It also brought the sketch because, of course, the feature was dependent on the sketch, but that's no longer the case. I'm going to uncheck this sketch and, again, hide my previous level. And now we've got the exact same features we did before, but we can interact with it synchronously. And as an example of that, I'm just going to reach in and grab this cutout in the middle here. And you'll notice live rules comes up. Again, we're not going into much depth of live rules. The only thing I'll tell you to do right now is turn off this lock to based reference plane. That just prevents features that are centered on that origin you see from moving. And in this case, just for demonstrative purposes, I want to click on that arrow and just start that move. And you can see that as I adjust my part, synchronous technology is maintaining that design intent. It's maintaining the tangency of those edges, the constant radii. Similarly, if I just hit escape to get out of that, I can put a box around a whole bunch of geometry, this whole piece over here, drop my steering wheel on that feature, and this time I'm going to readjust my vector, and you can do that with these directional controls. But just to show you, now I'm going to move that feature out, and you see that synchronous technology will automatically pick up on symmetry, which can be overridden, but right now it's recognized symmetry, and it's maintaining that design intent. So what I have is I have a fairly complex part, but I can kind of grab bits of it piecemeal and move them around to kind of adjust to any unforeseen design changes. So having a synchronous backbone to your part gives you that flexibility. And what we're going to do now is we're going to add some ordered features. Now, ordered features by their very nature are dependent. They're dependent on what precedes them. But we can build them to be dependent on a synchronous feature such that they will maintain a high degree of complexity but kind of move and adjust as we make changes to that original synchronous base feature. So what we're taking away from this is we're going to try it with a single synchronous base feature, and again we can have it a little more complex than we would an ordered feature because we don't have to fight with a sketch, and then we're going to build these ordered features on top of it. So let's give that a try. If you're not already in the ordered environment, just right click and transition to ordered. and you notice your toolbar is going to change. We still see our synchronous our synchronous protrusion down here. And now I'm going to create a cutout that's going to remove some of the material, make this a little bit lighter, a little bit more of a streamlined design. So I'm going to drop my cutout on this plane here, and it's going to take us into the profile. And this will look very familiar to anyone who's using ordered solid edge or a product like SolidWorks, Inventor. These are all ordered base modeling systems. Now we're going to offset these edges to kind of define an area that I'm going to cut out. So what I want to do is I want to go into the include command, and I'm going to, in the options, make sure that I've included with an offset in here. And then I'll pick up on an edge, hit check mark to accept it, and then key in a 5mm offset, and then set my direction. You see, by moving my mouse back and forth, I can set where that offset's coming from. Now let's keep going. Grab another edge. We can go up and hit that green check mark, or we can just right-click, and Solid Edge will remember that 5mm offset. So we can kind of just bounce around in here and grab all of these features or these edges and make offset sketches. Now I'm going to switch and draw some lines to connect them. So I'll just connect that endpoint to anywhere on that line, and I'll come straight down from this boss and connect there. Now last thing, I might want to add some dimensions to kind of solidify this. So let's pick up on that center there and that intersection point. Drop a distance between and make that 25. I'm using this radial menu a lot. It's a nice way to kind of, it prevents you from having to reach up to the toolbar all the time. Saves you a bit of wrist strain. Let's make that 125 degrees in there. And last, I'll grab a distance between and offset this 5mm. Okay, we got a lot of overlapping geometry here, so the last thing I'm going to do is reach up and grab my trim command. This is a really handy command. You can kind of click and drag and draw a cut through geometry, and it'll trim it away relative to the other lines of sketch that are in there. So we can kind of zoom in here and remove these different pieces. And now I've kind of got that profile of that cut that I want. Now again, this cut, this profile is tied to edges of synchronous geometry. So I'm just going to click check mark there and then drop that down 6mm. All right, let's add a couple more features to get this design going. I'm going to hit create a round to round out some of these bottoms in here. A nice way to save time is to grab, change your selection criteria. I'm going to grab a feature, and I'm going to put in a 2mm round, and that should grab any edge associated with that feature. Now, maybe I don't want these top edges rounded, so before I finish, I'm going to jump back to Face, and I'm just going to hold down Control and click on this top face, because that'll remove any edges on that top face from my select set, and then I'll hit check mark. So that's a nice fast way using those select tools to pick up what you want to. Okay, let's start a mirror command and just grab both those features. You can see they're now collecting under ordered. We still have our original base protrusion under synchronous, but let's grab those two ordered features and just mirror them in that center plane. And you can kind of pick that up from the coordinate system, or you can go over here and turn on your one of your base planes to find a usable plane, and that'll mirror that in there. And again, I can click Finish or right-click to finish that. Okay, I'll just turn off that reference plane. The last thing I want to do, maybe I want to throw a chamfer some of the edges on this face. So I'll pick chamfer here, and we're going to select a 1mm setback. And I'm going to switch my selection criteria to face and just grab everything on that face. And again, a green check mark or right-click to accept that and hit Finish. All right. Last thing, we want the same set of features on the underside. So I will just go and start my mirror command again. This time grab all those features, hit check mark, and I'm going to mirror them in that XY plane and hit Finish. So we can see that that's happened on the bottom. Okay, great. So again, if we click on Synchronous and jump back, there's our Synchronous base feature, sort of the start of everything. And in terms of best practices in Solid Edge, the only thing you really have to know is that Synchronous always comes before ordered. So your ordered features are all built on top of your Synchronous features, but what you're going to get is still the ability to grab onto that Synchronous face, even in the ordered environment, and make an adjustment to it. And because we tied all those ordered features to that Synchronous face and edges, they're just coming along for the ride. So we've got kind of, with that Synchronous base feature, we've got kind of a very fluid part that we can adjust. But because we've built sort of what I would call treatment features, these kind of cuts and rounds and chamfers, because we've built them in the ordered environment, we've got a high degree of complexity, but it doesn't kind of add to the overhead of that Synchronous base feature. So let's hit close and return and jump back into this assembly and take a look at what we've got. So there we've got that nice bracket joining those the forks here. Now, we need another one down at the bottom here. So what I'm going to do is I'm going to use my, I'm just going to click on that to select it, and I'm going to use this steering wheel to create another instance of this part down here. The steering wheel is a really handy thing in an assembly because it allows you to move things around. It's a pretty intuitive interface for how you set vectors and make translation or rotational movements. In this case, we want to start by picking our control point. And because we want to line up the bottom of this bracket with the bottom of this piece here, I want to click on that center knob of my steering wheel. Just click once so it's on the end of my steering wheel. And then I want to bring it around and just snap it to any face that's on the bottom there. And you can see that it'll swing my vectors around to adjust to that face. It usually will put a vector normal to the face. Again, if you need to make changes, you can use these directional nodes to kind of make those changes. But now we've got a vector pointing down, which is where we're going to move this. But we're not just going to move it, we're going to create a copy. So before we move, you want to reach up, and you'll have this toolbar will appear when you have something selected in an assembly. And I'm going to click the Move Copy command. And what I'm going to do is I'm going to click once, and that'll start that move. And then I want to bring it down and pick up on a key point on the bottom of that part. And if you can't pick up on the key point, just make sure that you've got center points or center and end points selected in your filters here. So I'll pick up on that, and now I know that that part is flush with the bottom. And you see that it's created another occurrence of that part in my tree. So right there, that's a really handy way to create another occurrence in an assembly. But I'm already seeing a problem. The diameter of this rod is quite a bit smaller up here than it is down here. It kind of flares out. So in fact, what we need is we don't need another occurrence of the same bracket. We need a similar bracket, but an entirely new part. And we're going to use some new functionality introduced in ST5. This replace part command, if we hit the little downward arrow to reveal more under the button stack, we got a lot more options now that have been added in ST5. What I want to do is I want to replace this part with a copy, meaning it's going to duplicate all the geometry I have but give it a new file name. So let's start that command and pick up on this part, which is still that original bracket we designed. And I'll hit the check mark. Now it's going to prompt me to give it a new part name. So I'll give this a new iteration of this part naming convention that we have here and hit save. And now you see that we have an entirely new part. It's still identical to the other one, but it's new. So how do we make this, this hole now adjust to the size of this shaft in here? Well, let's go into the part. So I'll click once on it, and we'll look for that Edit in Place button that'll come up. And now remember that that original hole was made in the Synchronous environment with that first base feature. So let's click and jump back to Synchronous. And I'll just again go and turn on my previous level of my assembly. This is normally in the View toolbar. I've added it to my Quick Access toolbar just to make it easier to grab. Okay, so we can like measure this shaft and then key in the value, but in Synchronous, we got some nice shortcuts we can take, and one of them are these face relate commands. One of the face relate commands is equal radius, and it makes the radius of a selected face equal to another one. So I'm going to start that, and you notice here we have the option of creating a persist relationship, meaning that if this shaft were to change size down the road, this boss would automatically update. So we can choose whether or not to invoke it. In this case, I'm still kind of in a design phase. I'm not going to invoke that, but I am going to click on that cutout there, hit my check mark, and then pick my target face, which is this shaft. And when I do that, you'll see that it updates the size of that hole. So I'll right-click to finish that. If we jump into ordered, what we're going to see is that all the cutouts, because they were linked to that synchronous feature, they've updated alongside with it. So that's an example of how these ordered cutouts are now dependent on that synchronous one. So we can use the flexibility of synchronous and have these complex ordered parts just go along for the ride. Let's have a look at a design change that we might encounter and how we're going to use these new ordered on top of synchronous features to deal with that. I'm placing a PMI dimension between these shafts. Oops. You want to make sure you grab the shafts. PMI dimensions, product manufacturing information, these are just good call-outs to kind of interrogate assemblies and figure out where everything's at. So I've created those two dimensions to show our relative offset between these forks. Let's say now that my manager comes in and tells me that we're changing the position of the forks relative to each other. These two are going to come back an extra 15 millimeters from the center shaft, and they're also going to be spread a further 20 millimeters out in either direction. So this is an example of a design change that I may not have accounted for. So to make that design change, if you think about how this might have been done before, if we had kind of these ordered parts holding everything together and assembly relationships, then holding the individual parts to one another, what we might want to be tempted to do is start with the bracket, make the adjustment, and then have things go. But another technique we can do, and this is kind of just gives us another option with the flexibility of synchronous, is let's make the changes to the part right now and then adjust things afterwards. So what I mean by that is that if I were to click on this shaft, and I'm going to hit spacebar and just grab this part as well, grab both of them, and using my steering wheel, I'm going to walk this back 15 millimeters. Now, it says that I will have violated assembly relationships. For right now, I'm not too concerned with that. I'm just going to suppress them because I know that once I make my changes to my other parts, those will come back. I'm then going to adjust this arrow and make a move in this direction 20 millimeters, which is what my boss was telling me to do. So now we've done that and our brackets don't fit anymore, but at least from an assembly perspective, these new parts are where they're supposed to be. So let's go in and make that change to our brackets. And we've already kind of done this at the beginning. If I go in, edit in place, and we jump back into synchronous, because that's got the base feature, that the general shape of our part, I can put a box around all this material here. Make sure that my live rules have symmetry set on, and then I'm going to just position my steering wheel just like we did before. Click on that center node once so it's on the end of your cursor, and if you bring it to the edge of the cylinder, it'll kind of want to snap on to the center of the cylinder. Now we can do a two-part move, so I'll set my vector in this direction, and I can either key in 15 millimeters or probably a little more conveniently just reach up and snap to the center of that. Let's do this move again. Again, Solid Edge remembers where my steering wheel was. I've got my minor vector already in the right orientation, so I'll click that to invoke the move in this direction, and I'll pick up again on that center point. Again, remember, your key point filter has to be set to center points to be able to grab onto that. But now you see that fairly quickly I've made that change to the synchronous feature, and when we jump into ordered, everything has adjusted accordingly based on the sketches that I created. Now we're going to have to do that again with this bracket because remember it's a different part. I'll show you an even faster way to do things. Without even leaving the assembly, I can change my select tool to face priority, meaning that it will pick up on synchronous parts. And I'm going to do a box just like I did before, and what it's going to do is it's going to find any synchronous faces that are underlying in that part. And I'll do the same thing. I'll position my steering wheel on the top of that hole, but I'm going to be careful to make sure that I've got the orientation flat, because what I'm going to do is I'm going to use this this disc in the center here, because that's sort of a planar move. That allows me to move in with 2 degrees of freedom along a plane. So if I click this, you'll see that as I move my mouse, it's adjusting that part in real time. And I'll just kind of zoom up and do what I did before. Just click, snap onto the end of that and click it once. So that saves us a bunch of clicks because we can access those synchronous faces right from the assembly. And I'll hit escape to end that command. We can access those synchronous faces right from the assembly, and we can do a translational planar move along to accommodate both those changes we made. That's a nice fast way of doing things. Now we got one more problem back here, and that's this bracket. This one we never touched, and he's completely out of place right now. So I'm going to jump back to to part priority, because that's going to let me select this part and position my steering wheel so that it's on top of one of these holes. Now what I can do is I can move the whole bracket back, but the span has gotten bigger. So I'm going to actually have to physically modify the bracket to accommodate that new span. So having my steering wheel on here, and again I'm moving, because I'm in part priority, I'm moving the whole part. I'm going to click on a move and just walk that back and just pick up on a key point here. So at least I know now the bracket is in line with these holes, even if it's not the right span. So using the steering wheel, we can it's kind of like another assembly relationship. We can physically move things into the right place. But I still need to make a modification to this part. So let's go in and have a look at how this part was constructed. I'll select it and I'll hit Edit in Place. And what we're going to see is okay, it's entirely done and ordered, and it looks like most of the geometry is in this top level protrusion, followed by a bunch of chamfers and some cutouts for the countersinks. So if I go in and edit the profile of this protrusion, what we're going to see here is just a mess. It's a very complex sketch. Again, I've just hidden the other level of the assembly. But you look at this sketch and it's kind of all over the place. Don't try this because you're going to make a mess of things, but if you try to, if you find this dimension and say, well, this looks kind of promising, this might be able to do what I want, notice that because of how it's constructed, we're not adjusting the position of this cutout here. So this is going to be a real headache trying to reprogram the sketch to make the changes we want. I'm just going to go back to the undo all, which will bring us back to how the sketch was when I opened it. And let's just get out of here, because this is a good opportunity for us to move one feature into Synchronous and then make that adjustment using Synchronous technology. So the way you convert things to Synchronous, and we did this once at the beginning, but any feature you pick can be moved to Synchronous, and the only catch is that it will move any feature that precedes it into Synchronous as well. And of course that's just because ordered features are always dependent on the features that preceded them, so we have to move them all together. In this case, it's just the first protrusion I'm going to move to Synchronous, so I'll select it, right-click, and go Move to Synchronous. And that'll go and put that into my Synchronous mode. So if I click on my Synchronous environment, we see that we have that protrusion, minus the countersinks, the rounds, and the chamfers, or sorry, just the countersinks and the chamfers. But I've got a nice medium in which to make these changes. So let's maybe hide those reference planes because they're kind of in the way, and just show the rest of that assembly. Now what I can do is I can box select, and depending on how I box select, it'll affect how things adjust. Remember, any face that's within the box you create will move. So if I do this, what I'll be moving is I'll be moving that back end of the cutout, but leaving the front end of the cutout here. Alternately, if I just hit escape, I could grab the front end of the cutout as well, in which case that would slide this whole triangle back with my move. Now in this case, I think I want to leave the front end where it is, so I'll just hit escape again and make my box one more time to grab all this geometry. And then what I'll do is I'll look for an appropriate control point, and that'll be this hole. So I'll click once on my steering wheel and drop it on the face of the hole. You want to be careful that you get the center of the hole. Sometimes it'll kind of jump onto an edge, so if it does that, just click and make sure you get that center point feedback telling you that you're on the center of that hole. And then we can click the Move command, and you see what happens as I move this is that it's adjusting this part, and I'll just go and pick up on a key point of that edge. And now if we look, we've got those holes lined up. Let's jump back into ordered by clicking on it in our Pathfinder, and we'll see that all of those features kind of updated as well. So, jumping back, we've made those changes using a combination of ordered and synchronous features. And this is just a good example of how the two techniques combined will kind of give you a degree of flexibility when you make these operations.